Here are solutions to homework set number 6 for ECE Port 76. This homework set looks at using math functions, random functions, and the matrix library with the Raspberry Pi Pico. So the goal of this assignment is to build a little reflex game, plot your reflexes, use the least squares curve fit to draw a line through the data. So here's how the game proceeds. I start the game, it clears the screen, and then waits for me to hit the button. That starts the game. Once the game starts, it waits a random time, plays the beeper. I then hit it, that shows my reflex time. That was 191 milliseconds. Hit it again, 269 milliseconds, does a linear curve fit through the data. Third set of data, fourth set of data. Each time I do it, I draw a linear curve fit through it. Waiting, waiting, waiting. And that predicts what my time will be on the 8th trial. So that's the idea. How do I get there? Well, the first thing I do is start with the display routine. I'm going to start with the random number generator. This is a gamma distribution, probability 0.5 for a mean of 2, probability of 0.5 for an exponential distribution. Sum of 3 of them gives you a gamma distribution. Come up with a gamma distribution with p equals 0.5, r equals 3. So here's the code, and if I try it for 5 times, okay, it looks reasonable. Next step, work on the display routine. I'm going to pass my data points on the x-axis, plot my times, pass my times, and have it display. So what that looks like is I'm going to test it. I'm going to give it data where I know what the answer is. I should plot, here's my times, 0, 1, 2, 3, 4. Here's my reaction times. Try it. See if my display routine is working. So here's my numbers 100, 2, 3, 4, and that guy. The line shouldn't be in there yet, but we'll add that a little bit later. Okay, so my display routine is working. Next, let's work on the least squares curve fitting. What I do here is I set up my basis function. So the basis is t and 1. This is doing the curve fit of y equals at plus b. My unknown is a and b, and y is my times. So I'm going to set up my basis function of n by 1 matrix. This is at least if you have 2 or more data points. The y matrix is an n by 1 matrix. Fill in b's as trials, t and 1. Y is the reaction time. I'll then do b transpose times b inverse. My least squares curve fit is a is b transpose b inverse b transpose y. With matrix routines, here's your b transpose times b inverse times y. Put all together, there's a. Kind of a sidelight, there is an easier way to do that using recursive least squares. We'll cover that in a future lecture, but we haven't covered that yet. Using the matrix routines, I can do least squares curve fitting this way. Then my linear curve fit will be a of 0 times 0, that's this point, plus a1. The last one is the slope, that's a, this is your a, here's b. A times 7 plus b. Try that, and for a known data point, there's my least squares curve fit. Looks correct. Now add the reflex game. So in the main loop, I wait for the game to start, then play for 8 rounds. I'm going to sleep for gamma amount of time, gamma distribution, t seconds. Let's see. Turn on the beeper, wait till I hit the button, record the time, turn off the beeper, start building up the array. So here is x. Goes the round number, starts out as 0, then 1, then 2, then 3, keeps on building it up. Y is the time delay. and display it. So here's what that looks like. Put her all together. All together, I start the game, waits t seconds. There's my first reaction time, 233 milliseconds. Second one, 196. There's my linear curve bit. Next one, 155. Consistently getting better so far. 165. Waiting, waiting, waiting. 171. There's my reaction time and the linear curve bit for my data. Predicting on round 7, this is where I'll be. Oops, that was a bad one. At that point, the game is over. So these are my reaction times. There's the linear curve bit based upon my data. And displayed in Thani, here's the times after each round. That is homework set, number something. Homework set number 6 for 476.